Hey everyone! So in this video we're going to be covering slope warping and also fix a bug that needs fixing. It was pointed out to me by someone in the Discord server, and he actually went through the work to create a fix, created that fix for it before I even had time to look into it, and so we'll actually be using that fix in this video along with the Power IK plugin for slope warping. So let's get into it. Okay, so to get started with slope warping, there is a plugin inside of the Unreal Engine Marketplace that has become free for everyone called Power IK. It is required for this video because they have their own solution, their own method for slope warping, which is easier than us just figuring out our own. So we're going to be using this plugin. Go ahead and install it to your engine. It's already installed to 4.26 on my end. It's just given me the option here and then tells me this because I have 5.0 early access on my computer and it won't work with that. Once it's installed, go ahead and go into your plugins menu. Go to installed and you'll find this Power IK plugin here. Enable it and restart the engine. It's asking me if I want to save some stuff, and it's asking me that because I just wrapped up recording the last video here. I actually record these things back to back, even though they're either 3 days apart or 2 days apart, depending on how you want to look at them. Now we can go into distance matching. Go into not animations, blueprints. I keep clicking the wrong folder. We're going to open up our distance matching animation blueprint. So we're going to go to our anim graph. And I'm going to go ahead and make a new state. We only want slope warping to occur when the character is on the ground. Our character is only on the ground. There's no jumping implemented yet, but there will be, and we will be covering distance matching with jumping in the future. So I'm gonna name this grounded. No, I'm gonna name this I'm not sure. I'm just gonna name it anim graph, I guess. I don't know. Because all of our locomotion is, I guess jumping would be considered locomotion. So we'll name it this locomotion without a J on the end. Okay, let's rename our regular locomotion to grounded locomotion. Let's connect locomotion to our output pose, and let's cut grounded locomotion. Go into our new locomotion state, add a state, name it grounded, and paste our grounded locomotion state machine inside of it. And so that'll give us the option to do jumping from here later on. Now, we'll drag out from grounded locomotion, and we're gonna just search. Actually, we can't drag out. Instead, right click and search Power IK ground. And then connect these, and it'll automatically connect it up between the two, and it'll automatically create the component to local nodes. Just gonna straighten this stuff up, and it says character root pelvis, and what it's really looking for is the top bone in the hierarchy that has control of all this stuff. It's directly part of the hierarchy of bones. Is an actual bone with deformation, and that would be our pelvis. So it's, if your wig's different, it would be whatever bone controls your hips and has both the torso and legs as children of it. So that will stay the same. Now we're going to add 2 array elements for this feet to the feet array, and the only thing we need to change here is bone name. The top one is going to be foot_L, and the bottom one is going to be foot_R. And now, if we just compile and save and go straight to playing, our character will rise up into the air. And that's because this ground IK node, what makes it so great is that it does all of its traces, it does everything from inside the node, and by default it's tracing and it gets the capsule too, and it hits the capsule, and so the character's risen up to be on top of the capsule, but the capsule rises up and it creates this odd situation here. And to get around that, we can, and my screen is doing weird things because I have a controller plugged in right now and it was on the floor, and a joystick was being pressed up against the floor and it was upside down. So where was I? Alright, so go to Edit, Project Settings, Collision. We're going to create a new trace channel, and we're going to name this IK Trace. And now, if we open up our preset expandable menu, we want to select Pawn and set it to ignore IK Trace. And Character Mesh, ignore IK Trace. We can close out of our project settings. We can go back to our Power IK ground node, collapse our feet menu, find ground, then you want to find this ground setting section, open up ground collision, and change the collision channel to IK Trace. So now if we compile that, our character walks along on the ground. So if we just move this, scale it up, and rotate it like that, we have slope warping. And it's that easy. But you might have noticed something. Someone definitely pointed out in the Discord that stopping doesn't always work correctly on slopes. And we need to fix that. The character has a tendency to freeze up, and so we can fix that by opening up our character blueprint. And, well, I'm using the fix suggested in the Discord by bitsalive.ron. So he actually selected that in the distance matching channel of the Discord server for this YouTube channel, which is linked in the description below. Be sure to join. This is his solution. He discovered the problem before I did, and he came up with a solution for it before I had time to, so we're just going to directly implement that. Now, this doesn't work on curved surfaces, and I'll be doing some R&D on that. But for now, this is good for handling slopes, and since we're doing slope warping, it would probably be a good idea to get our distance matching working with our slope warping. So the problem is that the trace for the stopping location is just it's just tracing straight out in front of the character. It's not taking slopes into account, and that can cause issues when the distance that the character travels while stopping and going down the slope is different than the distance that the character is predicted to travel, and they freeze just like that before they even hit it. Because it's just basic geometry. I can't recall the name of the theorem. So you have a right. You have your right triangle. You have your triangle. The hypotenuse is going to be the longer than the other two legs of the triangle. That's essentially what this is. It's calculating this for our imagine let's get Paint open. So, that was a horrible, horrible line. Alright everyone, I've opened up Paint for the first time in years, and so our trace is a horizontal trace. It's tracing horizontally, this line right here, from our capsule, which is our character right here. Or well, it's not tracing per se, rather it's just simulating forward, but it's assuming that the character is on flat ground. But if the character is on a slope instead, like that, now, well, this thinks that the character is going to stop over here. This character is not going to stop over here, because if we, let's grab a color and let's make this like, so this is where it thinks the character is going to stop. But if we take a line that's the same length, and I'm used to being able to rotate my selections and stuff in these kinds of programs. Oh my gosh, this is turning into a mess. I hate this program. But this is a longer distance, really. That's it. I doubt many of you really, if any, needed that horrible, horrible diagram. We are going to predict our stop location, and we're going to do a trace, a sphere trace by channel, up and down from that predicted position, and it is going to find, and whatever it hits, that Z is going to be the new Z of the location variable. So here I go to Paint again. So we have our slope, we have our predicted stop location, but our predicted stop location is here, because our character, our green box, is right here. And this isn't lining up well, but I don't really care. And so it gets this stop location, but then it's going to do a trace down to look for something that it's going to collide with. And in this case, it collides, let's find a new color, with this point here. And so it now sets our stop location to be this point right here, and if it hits nothing, it just sets the stop location to be this point here. Alright, that little graph diagram thing turned out a bit better than the first. Maybe I should rehearse that, though I only thought of it on the spot the first time. Anyway, let's do it. So we need a new variable, and it's going to determine the magnitude of the trace. And this variable is going to be named distance matching trace. Bits Alive named it distance, but I don't like having the I don't know, distance matching trace distance. It's two words close together there, so I'm gonna use magnitude instead. I'm going to bring this float out, and I'm going to get a plus and a minus. And now we can get rid of this set stop location here. Move our draw debug sphere. I'm gonna bring this out from out stop location, and I'm going to break this vector. And we want to add this variable to Z and subtract it from Z. We're gonna add it for our start, the start of our trace, and subtract it from the end of our trace. So we have our point, we trace starting way above it, trace to an area down it, and anywhere along that line, if there's something it collides with, well, it will reset, it'll change the stop location there. And we don't want this to be too high. We don't want it to be too low either. I haven't tested this under a whole lot of use cases. I think 300 is a good value. but you might have to change that for your own project, or you could get more advanced and create code to change that value. Or there's, because you don't want to trace into your roof of your building instead of the ramp you're walking up. And there's various ways to get around that. You can get pretty complex with it. You could set your roofs to be a different collision type so that the trace ignores them, and you could have your meshes that you can actually maneuver on register as a trace. But then what if you can also walk on the roof? So there are different ways to fix it. Heck, you could even trace up from the character's head, find the Z level of the ceiling above the character's head. Of course, you'd want to cap it at a certain distance, and then trace back down from that level and do that even. I don't know, but this works. This is simple enough. We don't need to get that complex. So, and there's an extra pin. Not sure why. So let's get a sphere trace by channel. Not multi-sphere trace, just sphere trace. And is it just me, or are these videos getting longer? Maybe I'm ranting more, like I just did there. Not sure. We're going to connect X and Y up on all of these. Our plus is going to go to start Z, our minus to end Z, our radius is going to be 0.1. And now we need to break our hit result, which we're going to split the struct pin. We're going to drag out from out hit location, and we're going to break the vector. And we're going to get our capsule component. There we go. And we are going to get scaled capsule half height. And we're going to add this to the Z of our broken vector. And then we are going to get a stop location variable, and we are going to get a set stop location variable. And we're going to split our struct pin, plug this into Z, and plug X and Y from our break vector into X and Y in our set stop location. Now, from return value in our sphere trace by channel, we're going to drag out from that, and we're going to get a branch. I'm going to add some reroutes to try to keep things a little bit more clean. Guess that might be as good as I'm able to get it. And I'm going to scoot some stuff around. And if it's true, we're going to do the setup that we just did with this set stop location. If it's false, we're going to just drag out from our predict stop location, set stop location, reroute node again, keep things somewhat clean, and we're going to plug that into false. I'm going to compile and save, and now if we run up the slope, we will actually stop. And it's not drawing our sphere. I forgot to connect that back up. So we can see that it's still not drawing our sphere because I only halfway connected it back up. In this case, I guess, I don't know, I think it's, yep, third time's the charm. We can see our sphere, and it is working correctly. We have slope warping, and we now stop on slopes. And thanks again, bitsalive.ron, for coming up with this suggestion and taking the time to figure this out, as you've really helped me. I'm actually recording this video a couple of days, a day before I go out of town for a week, and I'm recording stuff ahead, so I have stuff to post. And you gave me the other half of a video that I needed to not do even more thinking ahead. So thanks for that. And I think that's everything for this video. Alright everyone, I hope you enjoyed the video, and if you did, be sure to give it a like, and if you're enjoying the series and want to see more, be sure to subscribe to the channel and hit the notification bell. And I'll see you all in the next video. Thank you for watching.